When we mine and burn fossil fuels, we're burning carbon that was sequestered millions of years ago. And this changes the carbon cycle today. Today, we're going to look at how we can use solar fuel from the past. So, non-renewable energy sources can only be used one time. So, non-renewable energy sources include fossil fuel from oil, coal, natural gas, as well as nuclear fuel sources. So here are some of the different ways that non-renewable fuels are mined. So here we have some strip mining of coal in the top left-hand corner. We have some natural gas fracking in the top right. Oil mining in the tar sands. Now we can also drill for oil as well, and so it leaves less of a footprint in that way. And then we have uranium mining in the bottom right. So fossil fuels were made a long time ago. And this was the conversion of ancient plant matter to coal. So in ancient water sources or wetlands, the plant debris would then float to the bottom of the water. And then slowly, as sediments were deposited on top of the plant debris, it was compressed in the earth under heat and pressure. And slowly it changed that to a solid carbon source known as coal. And this happened over millions of years as that layer was continually compressed and put under pressure, and as more layers of sediments were put on top of it. And then as some of that coal was able to be accessed near the surface, we used it for fuel sources. So sometimes we can access this through underground mines, and sometimes we access this through strip mines where we take off the top layers of soil and then dig for that coal afterwards. About 70% of Alberta's electricity is generated by coal, because the availability of coal is there in Alberta, and there's a low cost to mine it. This has caused air pollution to rise due to the use of coal. So it contributes to things like smog, sulfur oxides, nitrous oxides, and carbon dioxide. So Canada's use of projected coal use is a little red line at the bottom there because our population is quite a bit lower. The United States is an orange line that's staying relatively steady but going up, and China is increasing their use of coal as an energy source, and the world's use of coal is projected to go up in the near future. So petroleum was also made a long time ago. Now, petroleums were made when we had a shallow sea that contained coral reefs with plants, and then eventually sediments would cover those plants, and then pressure and heat converted them into petroleum, and that petroleum was able to be trapped into rock sediments. A little bit different than coal, which makes its own layer. Petroleum can be trapped in between layers and can even permeate permeable rock, and then will be trapped by layers of impermeable rock. So petroleum in Alberta can be close to the surface, like in Fort McMurray, where you can take it out of the oil sands, or it can be buried deep within underground. So we need to drill down and take it out with pumps. So in Alberta, we use steam, chemicals, and now we can use liquefied carbon dioxide and water to help push that oil out and separate the oil from the sands in the oil sands. So we'll take water, push it underground into the same layer that the oil is in, and because oil is less dense than water, it will come out of the well, while the oil will fill up that space that the water will fill up the space that the oil took in the rock. Now, coal bed methane is a new source of methane for mining. And there's often methane trapped in the coal and dissolved water. So after we pump that water to the surface, the water and the methane are going to be separated, and then we can use that methane for fuel. So methane trapped in ice is known as methane hydrate. So as we put water into those coal layers, it'll often force the methane that's released from that water out, and we're able to send it to the pipeline, through a pipeline. So in fossil fuel power plants, there are some very general conversions that take place. So we have our fuel supply, in this case, coal. We're going to burn the coal to boil water. So that water is going to create steam that is going to spin a turbine, that's going to spin a generator, that then is going to create electricity. So then we want to cool that water down before we send that water back out to its source. So often you'll find big bodies of water next to coal-fired power plants so that they can take water in and put water back out. Now this does create an artificially warm water body, so it can cause some differences in the plant and animal life that lives in those water bodies next to coal-fired power plants. But that's our general flow of conversions through a power plant. Is we have the chemical energy of coal. We boil it to make thermal energy. We burn the coal to boil water to make thermal energy. Then that steam will spin a turbine, which is mechanical energy. We spin a generator that's mechanical energy and makes electrical energy. And then we send that energy along through power lines to our houses. So uranium is also a non-renewable energy source, and it's used in nuclear fission. And so we're going to have a whole section on nuclear fission that we'll talk about later in this unit. And the energy conversions in this are atomic energy from the nucleus of atoms. And then that atomic energy turns into thermal energy of the steam because we're going to boil water again. Then that's going to turn into kinetic energy that's going to spin a turbine, then a generator to produce electrical energy. So those are some of the non-renewable energy sources that we use in Alberta. And again, most of them except for nuclear energy originated with the sun. Now, renewable energy can be used over and over again. So some forms of nuclear energy that are used in Canada include solar energy, biomass energy, or the burning of wood-type fuels, hydropower energy, geothermal energy, and wind energy. So solar energy is energy that comes from the sun through solar panels and greenhouses. So we can have a direct conversion of solar energy to heat, or we can have an indirect conversion of solar energy, which is solar energy to electrical energy. And this is the photoelectric effect, which we'll look on the next few slides. So passive solar energy is through home design. So we want to have our roof overhanging so that the summer sun doesn't come directly in our windows, but the winter sun being lower can come into our windows. The more windows we have on the south-facing side of our house, the more availability of sunlight there is to the inside of our house. Also, if you have a concrete floor, this will absorb heat during the winter, and then it will release that heat once the sun has gone down. Also, having appropriate insulation in the floors, the walls, and the roof are going to help keep excess heat out, and the heat that we do want in the house, we can keep in during the winter. Active solar heating is when we have a pump and a heat exchanger that's going to take solar energy that we've turned into heat and water and circulate it throughout our house. So we're going to have a pump that's going to pump antifreeze up to the roof where it can sit in the sun. So you want a south-facing side of the roof and absorb thermal energy from the sun's energy. Then that warm antifreeze is going to come back down and go into the heat exchanger, where warm air is going to take that thermal heat and pump it throughout the house, and then it's going to send cool antifreeze back to the heat exchanger, where it can be pumped up to the roof again to absorb more solar energy. And so this is then going to help circulate the outside thermal energy inside the house, even if it's cool outside. So the photoelectric effect is a photovoltaic cell or solar panel. Now, this is typically made with 2 layers of silicone, and when a photon light strikes the silicone, this causes an electron to be released into one of the layers. An electrical field of positive and negative charges is set up, and then a current can be established where electrons move, and the current is able to charge a battery or run a load. So, solar energy charging a battery. We have a photon that strikes the panel, exciting an electron, which allows electrons to move through a circuit. Okay. So those silicone layers have charges with free electrons, and that electron is able to flow through the circuit to either charge a battery or to power a device directly. So those photons from the sun allow free electrons on the solar panel to complete the circuit. So wind energy is electrical energy that can be obtained with wind generators on wind farms. So the conversion flow of wind energy is solar because it heats the air, followed by thermal energy, the heat of the air, kinetic energy of the wind, then the mechanical energy of the turbine spinning, a generator creating electrical energy, and then we have a current that flows through that wire. So the sun is going to heat up the air, which is going to create wind, and spin our turbine to spin our generator to create electricity. So here's another example of how that happens. So we have warm air that rises, whether it's over the land, near the ocean, or just wherever the sun happens to be shining. As that warm air becomes less dense and rises, cool air from the ocean or another location comes in to fill its place, which creates our wind. So hydro energy also uses solar energy as its initial form. So solar energy causes water to evaporate, which then will rise and condense to form clouds and fall as precipitation in locations farther inland. So we have solar energy causing water to fall in mountains and hills. Then we have gravitational potential energy because we've taken a dam and we have water now at a higher level behind the dam and a lower level in front of the dam. So we have gravitational potential energy of that water to fall down. Then we have the kinetic energy of the water moving through the pipes, which turns turbines causing mechanical energy, which will then spin a generator to create electrical energy, which then we can send down a transmission wire to our homes. So here we have the water cycle where we have to start with solar energy to have transpiration and evaporation, followed by precipitation, and then we're going to catch that surface runoff and stream flow behind a dam to create that gravitational potential energy. So biomass energy is renewable energy that was obtained from materials that were living, but it's not fossil fuels. It's a kind of short cycle carbon, such as trees, plants, and waste materials. So our energy conversion is going to start with the sun, which is solar energy. Then we have chemical potential energy stored in the bonds of fibers of trees, of manure, of other plants. Then because we're burning it, we're creating thermal energy, followed by kinetic energy of the steam of the water that we heated up, mechanical energy of a spinning turbine to a spinning generator, which is going to create electrical energy, and then we're going to send that energy, electricity, through a wire. So photosynthesis is the basis of biomass energy because we create those sugars, starches, and celluloses, which then we can burn in biomass fuel. So again, here we heat water to make steam. We spin a fan or a turbine, then we spin a generator to create an electrical current that we can use to send energy to our homes. We also have ethanol biomass production, which is, again, part of the carbon cycle because we have carbon dioxide that's originally absorbed by crops like corn, which will be finely ground up, separated into their different sugar components, and then they're going to be distilled to make ethanol in a fermentation process. That ethanol can then be used as an alternative fuel source compared to petroleums, and in Alberta, it's added to our gasoline. We have up to 10% ethanol added to our gasoline. That gasoline is then going to be released as carbon dioxide and the ethanol, which then will be reabsorbed by the original crops. So if you have a pure ethanol burning vehicle or biofuel vehicle, you're using only short cycle carbons and not burning those carbons from the carbon sinks and petroleum sources. Now, tidal energy is a non-solar renewable energy because it uses gravitational pull of the moon and the sun to convert the movement of water into electrical energy. And so we can do this at places such as the Bay of Fundy because there is a very large movement of water through the tides. So the energy conversion is going to be gravitational potential energy through the high water. And then we have kinetic energy of the water moving through the tidal energy generating station. So it will then spin a turbine, spin a generator, which will create electricity, and then we can send that electricity through a wire. Now, tidal energy is only useful in a few places, and one of them obviously has to be near the ocean. And lastly, geothermal is another non-solar form of renewable energy because this uses the heat from radioactive decay in the earth. So then if we have hot enough water that has steam already in it, we can use that steam to generate electricity. So we have the nuclear energy from radioactive decay, and this creates thermal energy in the form of heat. Then we have mechanical energy in the form, or kinetic energy in the form of a steam. Then a mechanical energy as a turbine spinning a generator creates electrical energy, and then we can send that wire on its way. Now, geothermal energy in lower temperatures can also be used for heating purposes, because you can take that warm water from the ground and pump it through walls or streets or sidewalks and to warm things up from underneath. But it wouldn't be hot enough necessarily to produce electricity. So those are our forms of energy sources, both renewable and non-renewable.